Hi, I'm Miss Hearn. Let's get started. Now we're going to talk about graphing functions by plotting point. It says graph the given functions f and g. So it's not only f of x, we can actually give any letter name. We commonly use g, h, j, k. When we have to talk about two different functions in the same scenario, then we'll give two different names so we can distinguish between the two. It's sort of an advantage instead of having to use y equals negative 4x and y equals negative 4x minus 5, where we might get the two y's mixed up. Really, these two notations are just y values. So we're going to plot points. Plotting points is not the most efficient method of graphing, but when you're first getting used to certain new equations that you're not familiar with, we often use plotting points to just get a feel for them. You probably already know, you should know that these are lines, y equals negative 4x and y equals negative 4x minus 5. You might also recognize their slopes are both negative 4, and so they should be parallel lines. But we're going to be graphing functions you're not familiar with in this section. And in that case, what I want you to do is I always want you to plot a few negative values, 0, and a few positive values, unless I tell you in the instructions, I tell you otherwise, because there will be functions like the square root function where you can only plot 0 and up or whatever. But if I don't tell you, just make a little XY chart and plot like negative 2, negative 1, 0, 1, and 2. Or you can do more on either side of 0, but make sure that you at least do a couple negatives and a couple positives and 0 itself. This is our XY chart, but we're not calling it y anymore, are we? We're saying we have a function, so we can call this f of x. And what does f of x tell you to do? It tells you to take your x, whatever it is, and multiply it by negative 4. So if I plug in negative 2, we're going to get negative 4 times negative 2 is positive 8. Plug in negative 1, negative 4 times negative 1 is positive 4. 0, we get 0. 1, we get negative 4. Multiply 2 times negative 4, we get negative 8. Okay, so let's go ahead and plot f of x. So we have 0, 0. We have 1, negative 4. I like to label my coordinates unless they're on the origin. 2, negative 8. Okay, we have negative 1, 4. And we have negative 2, 8. And then we're going to put a line in there. So that's f of x. And now maybe in red we'll plot g of x. But again, I want to use a couple negatives, negative 2, negative 1, 0, 1, and 2. So g of x takes this number and plugs it into negative 4 times x minus 5. So for each of these numbers, we must multiply by negative 4 and then subtract 5. So for negative 2, we have negative 4 times negative 2 minus 5. That's going to be positive 8 minus 5, which is 3. For negative 1, we're going to have negative 4 times negative 1 minus 5. So that's going to be 4 minus 5, which is negative 1. For 0, we get negative 4 times 0 minus 5. That's going to be negative 5. For 1, we get negative 4 times 1 minus 5, which is going to be negative 4 minus 5 is a negative 9. And for 2, we're going to have negative 4 times 2 minus 5 is negative 8 minus 5, which is negative 13. All right, so just to be clear, what are we saying here? We're saying that our function g goes through the point negative 2, 3, the point negative 1, negative 1, the point 0, negative 5, the point 1, negative 9, and the point 2, negative 13. All right, so negative 2, 3 would be here. Negative 1 would be here. 0, negative 5 would be here. 1, negative 9 would be here. And 2, negative 13 would be here. Okay, and then we're going to put in our line. Okay, so these two lines are parallel. One of them is just lower than the other one. The red line is just 5 units lower than the blue line. And there's a reason for that. It's because we subtracted 5 from every y value. So that's why that happened.
I hope you found this video useful. If you did, please remember to like it.